Hello students. Today we studied combination of resistors. Okay, combination of resistors we've also studied in class 10, and in class 12 we'll start from the basic networks, and then we'll go up to complicated networks. Then we'll study Kirchhoff's laws to solve very complicated networks. Then we'll also study infinite networks, and we'll do some very nice and IIT questions, IIT level questions. Okay, so we know resistors can be combined in series as well as parallel. So if you have a series combination, let us say two resistors which are connected in series, then here when you switch on the key, whatever will be the potential difference, current will start flowing. Let us say this is R1, this is R2. So R1 and R2 are connected in series because the current I is same which is flowing through both the resistors. Okay, what gets divided over here? The potential drop gets divided. V1 and V2. The potential drop in both the resistors will be different. So we know V is equals to V1 plus V2. V can be written as IR. Okay, I can write IRS because it's a series combination. V1 is equals to IR1 plus V2 will be equals to IR2, right? The potential drop across this resistor R1 will be IR1 and potential drop across R2 will be IR2 because current is same. So taking I common, RS is equals to I, R1 plus R2, or RS is equals to R1 plus R2. If there are n resistors, then R1 plus R2 plus R3 up till Rn. So that's the equivalent resistance for resistors connected in series. What if we have a parallel combination? If you have two resistors connected in parallel, R1 and R2, and they are connected across a battery, then when you switch on the key, potential of the battery is V, current I will be derived from the battery, and this current I will be divided into I1 and I2 because there are two paths for the current to flow now, right? What remains same over here? The potential drop remains same, and what gets divided? The current gets divided. So we can write I is equals to I1 plus I2. What is I? The current, the full current of the circuit. So we can write using Ohm's law I is equals to V by R. I am writing this R as Rp because here we are having parallel combination. What is I1? I1 will be equals to V by R1. The potential across resistor R1 will be V by R1 plus I2 will be V by R2. Right? I hope this is the kind of revision. All this we studied in class 10. So V, taking V common, 1 by Rp is equals to 1 by R1 plus 1 by R2. That is the equivalent combination of two resistors connected in parallel. If we have n resistors, then 1 by R2 plus 1 by R3 plus 1 by Rn, like that. Okay. If you have only two resistors in parallel, then the shortcut is Rp will be equals to R1 R2 upon R1 plus R2. Okay. This will be the formula which will be used to find the equivalent resistance. If there are more than two resistors, then you can apply this formula. So quickly let us take two easy numericals for series and parallel combination. Here let us say that there are two resistors connected in series, 2 ohm, 4 ohm and a 12. They are connected across a 12 volt battery. Okay. The question is find potential drop and current in each resistor. So since it's a series combination, we know current I will be same. How to find I? For that we need the total resistance because here we have the total potential. So for that we need the total current. For total current we need the total resistance. So we know Rs is equals to R1 plus R2. That is equals to 2 plus 4, that is 6 ohm, right? So current I will be equals to V by Rs. What is V? 12 by Rs is 6, that is 2 ampere. So current in the full circuit is 2 ampere. what is current in each resistor. Current in R1 is equals to current in R2 is 2 ampere because current will be same. Potential drop across each resistor V1 will be equals to I R1, that is equals to 2 into 2, that is 4 volt, and V2 will be equals to I R2, that will be equals to 2 into 4, that is 8 volt. So see, for the check also you can see V is equals to V1 plus V2, 12 is equals to 4 plus 8, right? Similarly, you have a simple 2 resistor parallel combination. Again, let us say the battery is 12 volt, R1 is 3 ohm and R2 is 6 ohm, for example. Again, same question, find the current and potential drop across each resistor. So here the current I will be for the full circuit, full current, that will get divided into I1 and I2. Okay, what remains same over here? The potential. So we know that the potential across R1 is equals to the potential across R2, that is what? 12 volt. So how to find the for total current? First we need to find the total resistance. So we know since there are only 2 resistors, I can use directly the formula Rp is equals to R1 into R2 upon R1 plus R2. Okay, 6 3s are 18, 6 plus 3 9, that is 2 ohm. So equivalent resistance is 2 ohm. What will be the equivalent current? I will be equals to V by Rp, that will be equals to 12 by 2, that is 6 ampere. Okay, so this full current of the circuit is 6 ampere. Now what is I1 and what is I2? So for that we can use I1 is equals to V by R1. Okay, so V by R1, what is V? 12 by 3, that is 4 ampere, and you can use I2 is equals to V by R2 is equals to 12 by 6, that is 2 ampere. So see, 4 plus 2 is 6 ampere. I is equals to I1 plus I2. I'll give you a trick or a formula to find out the current in the parallel combination. If you have parallel combination network and you have to find current in each branch, then see, we have I1 is equals to V by R1, right, for the 2 resistances, and I2 is equals to V by R2. So if we divide these 2 equations, what will be? I1 by I2 will be equals to 1 by R1 is to 1 by R2, right? That is equals to R2 by R1. So I1 upon I2 is equals to R2 upon R1 if you take 2 resistors. Okay, so current ratio of current is equals to the reciprocal of the ratio of the resistances. Okay, let's check this one only since we did the same question right now. So we can write I1 is equals to I1 upon I2 is equals to I2 upon I1. I2 is R2 upon R1, that is 6 upon 3. Okay, so that is equals to 2. That means I1 is equals to 2I2. Right, we got one equation, and we know that I1 plus I2 is equals to 6 ampere because total current is 6. So I1 plus I2 is 6. So writing I1 is equals to 2I2 plus I2 is equals to 6 ampere. So that is 2I2 plus I2 is 3I2 is equals to 6. That means I2 is equals to 6 by 3, that is 2 ampere. See, I2 is same, we got I2 as 2 ampere, and what will be I1? I1 will be equals to twice of I2, that is 2 into 4, 2 into 2. 2 into 2, that is equals to 4 ampere. Right? So we got the same result. So you can use this formula, I1 is to I2 is equals to R2 is to R1. Okay? I1 is to I2 is to I3 is 1 upon R1, 1 upon R1 plus 1 is to 1 upon R2 is to 1 upon R3, like that if there are 3 resistors. Okay? We'll take that numerical also. Let's solve this question. We have battery of 10 volt is connected across this network. 2 ohm, 3 ohm, 6 ohm are connected in parallel, and this combination is connected in series to a 4 ohm resistor. The question remains same: find current and potential drop across each resistor. So first we need to find the total current. For that we need to find the total resistance of the circuit. First we will solve this. So we know 1 by Rp is equals to 1 by 2 plus 1 by 3 plus 1 by 6. 1 by R1 plus 1 by R2 plus 1 by R2. LCM is 6. So that is 3 plus 2 plus 1. 6 by 6, that is equals to 1 by 1. So Rp is equals to 1 ohm. Okay. We got the equivalent of this network is 1 ohm. Now this 1 ohm is connected in series to the 4 ohm resistor. So our equivalent is equals to 1 plus 4, because that is connected in series, that is 5 ohm. Okay, so the total resistance of the circuit is 5 ohm. So we can find the total current. I is equals to V by R equivalent, that is 10 by 5, that is 2 ampere. Okay, so 2 ampere current is flowing in the circuit like this. Now this 2 ampere will pass through 4 ohm resistor, and this 2 ampere only will get divided into I1, I2, I3. Right? So first we can find we know current in 4 ohm resistor will be equals to 2 ampere. What will be the potential drop across the 4 ohm resistor? We can find V is equals to IR using this. So we know current in the 4 ohm resistor is 2 and resistance is 4. Okay, so 8. 8 volt is the potential drop across 4 ohm resistor. So the total potential is 10. If here we have 8 volt, then the remaining potential will be across this. This network will have 2 volt potential, right? So that 8 plus 2 we get 10 volt. So now we know the formula that I1 is to I2 is to I3 is equals to 1 upon R1 is to 1 upon R2 is to 1 upon R3. Okay, so that is 1 by 2 is to 1 by 3 is to 1 by 6. Right? Again, taking LCM, what do we get? 1 by R1 plus 1 by this LCM will be 6. So I1 is to I2, you can find I1 is equals to 2 into 3 by 6. 2 into 3 by 6, that is equals to 1 ampere. So I1 is 1 ampere. Similarly, you can find I2 is equals to 3 into 2 by 6. That will be equals to 3 into 2 by 6. Right. That will also be 1 ampere. Okay. And I3 will be equals to 6 into that will be 2 by 3. 2 into I1 is 2 into 3 by 6. 2 into 3 by 6, that is equals to 2 3 is 6, 1 ampere. I2 is equals to 2 into 2 by 6, that will be equals to 2 3 is 6, that is 2 by 3 ampere. And I3 is equals to 1 into 2 by 6, that is again 1 by 3 ampere. Okay, so I1 plus I2 plus I3 will be 2 ampere, right? We have 2 amperes divided into I1, I2, I3. So we got this. Alternate method can be, you know, the potential drop across this full network is 2 volt. Okay, so you can find I1 is equals to V by R1. What is V is equals to 2? Potential is 2 by R1 is 2, that is equals to 1 ampere. See, I1 is 1 ampere. I2 is equals to V by R2, that is equals to 2 by 3 ampere, 2 by 3. And I3 is equals to V by R3, that is equals to 2 by 6, that is 1 by 3 ampere. So we are getting the same result by any method. So you can use this formula as well as this conventional method, right? The next network is given like this. You have two parallel resistors and one resistor is connected in series. So I have named the resistances R1 12 ohm, R2 6 ohm, R3 is 3 ohm, R4 is 12 ohm, R5 is 4 ohm. Okay. When the battery will be connected, current I will pass like this. This I will get divided into I1 and I2 through R1 and R2. I1 and I2 will join to give you I. Current I will pass through R3. Again that I will get divided into I3 and I4. I3 and I4 will again combine to give you back I, so that you get I back. Okay. So first, in order to find the total current I, we need to find the total resistance. So total resistance, first we will solve these two equivalents parallel. So Rp is equals to 12 into 6 upon 12 plus 6. 12 6 are 72 by 18, that is equals to 4 ohm. And Rp of this network will be equals to 12 into 4 upon 12 plus 4, that is equals to 48 by 16, that is equals to 3 ohm. Okay, now this network is of 3 ohm, this network is of 4 ohm, and we have a 3 ohm in between. So we can write our equivalent is equals to 3 plus 3 plus 4, right? 3 plus 3 plus 4. I hope you are getting. The circuit will be like this. This is RP1, okay, RP1, then you have the 3 ohm resistor, and then you have RP2, okay. This is connected across now the 10 volt battery. This circuit will reduce to this circuit now, right? So our equivalent is 10 ohm, okay. So I will be equals to V by R equivalent, that is equals to V is 10, so 10 by 10, that is 1 ampere. So the total current I drawn by the battery is 1 ampere. Now this 1 ampere is divided into I1 and I2, so we need to find I1 and I2. So we know I1 upon I2 is equals to R2 upon R1. So R2 is equals to 6 and R1 is 12. Okay, so we can write, this is 1 by 2. So we can write I1 is equals to 1 by 2 I2, or we can write I2 is equals to twice I1. Okay, plus we know that I1 plus I2 is equals to 1 ampere. See, this 1 ampere is getting divided into I1 and I2. So we can write I1 plus twice I1 is equals to 1 ampere. So thrice I1 is equals to 1 ampere, or we can write I1 is equals to 1 by 3 ampere. If I1 is equals to 1 by 3, right, I1 is equals to 1 by 3, then I2 is equals to twice into 1 by 3, that is 2 by 3 ampere. So we got the current through I1 and I2. What will be the current through R3? R3, the current will be I, that will be 1 ampere only. Okay. Then again this 1 ampere is getting divided into I3 and I4. So again we can write I3 upon I4 is equals to R4 upon R3. What is R4? Okay, that is equals to 4 upon 12. Okay, that is equals to 1 by 3. Right? So we can write that I4 is equals to 3I3. Again I4 plus I3 is equals to 1 ampere. So 3I3 plus I3 is equals to 1 ampere. 3I3 plus I3 is 4I3 is equals to 1 ampere, or I3 is equals to 1 by 4 ampere. So you got I3 as 1 by 4. So I4 will be equals to 3 times of 1 by 4, that is 3 by 4 ampere. So you got the current across all the resistors. And what about potential difference? See, this equivalent circuit RP is of 4 ohm. So, and current through this is, total current is 1 ampere. So 4 into 1 I into R, the potential drop across these these resistors will be 4 volt 4 volt. Here potential difference will be equals to 3 into 1, that is 3, and here it will be equals to 3 into 1, that is 3. So potential drop will be equals to IR, right? So this is how, using Ohm's law, we can solve complicated networks. Okay. Then in combination of resistors, you also get such kind of questions to solve these complicated networks. So find the equivalent resistance between A and B. So here points A and B are given, and this full circuit is connected between the 2 points A and B. You have to find the equivalent resistance between A and B. So what do? We keep saying that which resistors are in series, which are in parallel. We go on solving from the other side till we come to one resistor between A and B. So see here, we can see if we start from this point, here 2 ohm and 4 ohm, these two are connected in series. Now a question will be how to find which resistors are in series. So you can see if for example you connect an imaginary battery across A and B. Okay. Now if this is the positive terminal, current I will flow like this. Okay. Now this current I will get divided here into 3 branches. See, I1, I2 and I3. Right? 3 branches. Now see here, this I1 doesn't have any other part, so same current I1 will flow through 4 ohm also. That means 2 and 4 are in series. Then here there are 2 different currents. That means I2 is in parallel with this combination, right? Then here, see, I2 and I1 will come and combine here to give here. See, this is I3, here this will be I1, this will be I2, right? So I1 plus I2 will be flowing through this network. From here you will get I3, so this will be back I1 plus I2 plus I3. What was I1 plus I2 plus I3? I, because I was divided into I1, I2, I3. So remember, whatever current you draw from the battery, the same current you have to return to the battery. This is very important. So with the help of this current distribution, you will come to know that which resistors are in series, which are in parallel. So see, these 2 and 4 are in series. So 2 plus 4 will be 6. Now 6 and 3 are in parallel. So your resistance network reduces to, this is 2, this is 3, this is 3, and here you get this as 2 plus 4, 6. Okay. Now these 3, 6 and this 3, all 3 are in parallel. Can you see? This and this, because current is divided into I1, I2, I3. All 3 are in parallel, and then this parallel combination is considered in series to 2. So 1 by Rp is equals to 1 by 6 plus 1 by 3 plus 1 by 3. LCM will be 6. 1 plus 2 plus 2, that is equals to 5 by 6. So Rp is equals to 6 by 5 ohm. So here this combination is 6 by 5 ohm, that is in series with 2. So R equivalent is equals to 2 plus 6 by 5, that is 10 plus 6, 16 by 5 ohm. Okay. So the equivalent resistance between A and B is here 16 by 5 ohm. This is how we solve a complicated network. This question, similarly, again draw a battery like this, imaginary battery, draw current from the battery, current I, see here the current will get divided into I1 and I2. Okay, here this I2 will get divided into I3 and I4. Okay, now I2 is getting divided into I3 and I4. This I3 gets again divided here into two branches. That same current will here pass through this. Okay, so I3 will come back over here. So what we can see here, 12 and 6 are in parallel. So your network reduces to this equivalent of 12 and 6 will be 12 6 are 72 by 12 plus 6 18, that will be equals to 4 ohm, right? So we get this is 72 divided by 12 plus 6, that is 18 3s are 18 4s are 72. So 4, this will be 4 ohm. Okay, this is 6 ohm. Now these two are in parallel with this 10 ohm, right? See here, this is now 6 ohm. Okay, and this pull is connected across like this, AB. Okay, now 6 and 4 are in series, so 6 plus 4, 10, 10 and 10 are in parallel. So 10 into 10 upon 10 plus 10, that will be 100 by 20, that will be 5. So this combination will be equals to 5 ohm in parallel with 6 ohm, and here this is connected across A and B. Okay, now you can find the parallel of 6 and 5. So this is how we solve complicated networks. I'll give you one homework question and you please solve that and tell me. Homework question is, equivalent resistance between A and B. 1 ohm, this 2, here there is one wire, 3, 6 are connected like this, 2, 3 and A and B are here. So please solve this as your homework question and let me know. Thank you.